Hello, let's try another Leetcode problem. Number 143, reorder list. So basically, we are giving a linked list, and what we're gonna do, we're gonna do some insert operations. For example, this is the first node, the second node, third node, and fourth node. What we're gonna first do is to put the last node between the first and the second node. So this becomes 1, 4, and 2. And then we're gonna find the last node. If it can put in between this node 2 and another node, but there's nothing in between, so we cannot put it inside. And for this one, it's also the same. First, we put the last node between this 1 and 2, so it becomes 1, 5, and node 2. And then we're gonna put this node 4 between 2 and 3. So we're gonna put 2, 4, and 3. Yeah, basically for linked list, we're gonna use some operations to connect them and make it a new connection. So for this problem, we must use the in place operation. So here, yeah, you may not modify the values in the list node. Only nodes themselves may be changed. This means you cannot put values inside the linked list, and you cannot use a new linked list to prepare another head. Yeah, so you have to prepare everything in place. You just need to disconnect and connect the node. Yeah, so for this question, it will be 3 steps. Let me first explain it in the whiteboard. Yeah, for example, we have a linked list 1, 2, 3, 4, and 5. For this kind of a problem, normally I will prepare a dummy node. So this is my dummy node. Yeah, and then I will use the first step will be slow pointer and fast pointer because I want to find the midpoint. So the midpoint, if the number of node is odd, I will prepare the midpoint in the middle. If they are even, like 1, 2, 3, and 4, I will prepare at the right side. Yeah, because according to the definition of the problem, I need to put it to the right side. Yeah. You may ask why I need to put it to the right side. Because according to this definition here, so for example, this is 1, 2, 3, and 4, and what about the middle node is 2 or 3? If we prepare 3, for example, if we find the middle node 3, so the 3 dot next should be none. And this is another linked list, it's 4. We can directly put this 4 between 1 and 2. If we find the middle node is 2, we have to prepare 2 node, first 4 and then 3. But we don't need to prepare that 3. Yeah, so this is in the odd, if the total number of the node is even, we just need to prepare the middle pointer at the right side. Yeah. So this is the first step. We have to find this pointer in the middle. After that, we will prepare 2 linked lists. The first one will be dummy node pointed to 1, 2, and 3. This one will be pointed to none. So the second one is 4 and 5 pointed to none. Yeah. This is the first step. How can we find the 4? We just after find this node, we just use the next. This dot next should be a pointer p. For example, I use a pointer p to define this node. Yeah, so the p should be pointed to this node 4. Yeah, so this will be a p pointer. Yeah, the second step, I need to reverse this linked list. So 4, 5, none should be 5, 4, and none. So here I will use another pointer. Here I used a tail. Yeah, so I will use a tail pointer. Yeah, and after that it should be easier. I just needed to put 4, 5, and 4 in between 1 and 2 and 2 and 3 respectively. So this should be easier. I just needed to check if I have a node 5, I insert it between 1 and 2, and the pointer should be shifted here. For example, this is the head. Yeah, this is the head pointer. Yeah, what about the next step? I just needed to take this node 4 and put it in between 2 and 3. After that, I just need to return dummy.next. So that is the result, because here is always a dummy pointed to this 1. So the dummy.next should be my result. Let me go to the code to explain it. Yeah. I I don't want to write the code, because for linked list, if there are too many operations, actually it takes time. You have to make a drawing in a paper, and then you're gonna check your operations with this whiteboard. You have to check the whiteboard, and with your code, you have to disconnect and connect for reverse. Yeah, we did a lot of linked list reverse problems. We basically know how to reverse a linked list. And this one is also easier. And for the first part, it's also easier because we use the slow and fast pointers. We're going to find the midpoint. The only difficult part may be the second one. If you did a lot of reverse linked list problem, yeah, for the second part, it should also be easier. Now let me explain my code. So I will define a dummy node. It should be equal to the slow and fast pointer, and should be pointed to an empty node. After that, the dummy node should be pointed to head. Then I will use the slow and fast pointer to find the midpoint. Yeah, according to this, I find the midpoint. So here, this p pointer is the slow.next. This means I will find the head of the second array. This is p. So for the second linked list. So the first linked list, slow.next, should equal to none. So here, from this operation, it is the meaning of find the mid node. Basically, it is here. Yeah. From here, we get this 1, 1, 2, 3, and 4, 5, none. This is the first step. So the second step will turn 4, 5 to 5 and 4. So this is the second step. So this is the same like reverse linked list. We prepare a pre and current node inside. So if not current, we just return the previous. So this is just a template code. If we did a lot of reverse linked list problem. After that, we just need to return this current and next. Yeah. And the final step would be the insert. Let me explain the insert. Yeah, so the insert part is easier. I just need to check if there is a tail. So this tail pointed to node 5. If there is a tail, so this tail, I need to prepare the tail.next, because this tail should pointed to some other node. So I will prepare a next. So this next, yeah, this next is the tail.next. Yeah, so I will prepare a next. So this is the first line. Next equals to tail.next. After that, the tail.next. So this 5 should pointed to the head.next. So the head is 1. Head.next is 2. So it means, yeah, this 5 will pointed to 2. And also the head should pointed to this tail. So this is here. Yeah. So the head.next should pointed to tail. This is the third line. So for the fourth line, after that I connected, my head is at this position 1. I need to be shifted to this position 2. So the head should equal to head.next next. So the head goes to here. So this is my new head. Yeah. After that, I need to take my tail. So the tail should equal to next. So where is the tail? So the tail before it's 5. Next, it's 4. So when tail equals to next, I will prepare another tail. So the tail will be pointed to this 4. Yeah. After that, I'm going to check while there is a tail. So of course, there is a tail because the tail pointed to 4. Yeah, and then I'm going to make another connection. So this connection will be 2, 4, and 3. Yeah, 3 to none. So what about the tail? The tail should be none. So I will jump out of the loop. So this is basically the entire code. So I'm going to return dummy.next. Yeah, let me submit it just to make sure the code really works. Yeah, as you can see, it really works. So for the linked list, basically it takes time, but we have to be patient to put our ideas, put our thinkings into the code and make it working. But it's not so hard. Just it really takes time. Thank you for watching. If you think this is helpful, please like and subscribe. See you next time.